Okay, so we're moving on to multi-step equations, and we actually have pretty much all the tools we need to solve these kinds of equations. Multi-step is just as it sounds. So before we were solving equations in one step, whether that was addition, subtraction, or multiplication, division. Now we might have two steps. Okay, so that would be something like this. Okay, so we have an equation. We need to solve it in two steps, right? So we still want to end up with x equals something, right? That's our goal. We want to get x alone. We just have to transform multiple times. Okay, transform, remember, is when you do the same thing to both sides of your equation. That's the only way they'll stay equal. Right, so I really recommend doing addition, subtraction ones first. And then you do your multiplication, division second, like those transformations. The reason why is if you try and do multiplication, division first, I find it, you have to distribute, and it just leads to a lot more errors. So it's actually simpler if you do addition, subtraction first. Right, so we want to work slowly towards getting this x by itself. So I first want to focus on getting rid of the plus 6. So the way I can do that, right, just like what we did before, I'm going to subtract 6, and I have to do it to both sides. Okay, so I can carry down 2x. That's the only difference. Right now I'm carrying down like this whole number, not just x, because we have 2 times x. 8 minus 6 is 2. Right, and then now I'm going to do my multiplication, division. You can do it either way, whether it's multiply by the reciprocal, right, like multiply by 1/2, or you can do the divide both sides by 2. You're going to get the same answer, whichever way you prefer. You get x equals 1. Right, so we got multiple steps there. So there's not really a new lesson or anything. This is kind of just applying what we did to slightly more complicated problems. Okay, so I want to get rid of this 5. Just because the variable is second, that doesn't matter. I'm going to still aim to get rid of the 5. So I'm going to subtract 5, because that's a positive 5. Right, that gives me 0. I'm left with, pay attention to that subtraction, minus 3c equals 12. So it's negative 3 times c. The opposite of multiplying is dividing. So I'm going to divide both sides by negative 3. Leaves me with 1, right, which is what I want. Negative 4, and I get c equals negative 4. Do one with a fraction. Again, I always like to do the plus or minus. Multiply by the reciprocal. So I get 1. Right, this leaves me with 1. I get x equals 45. Don't get fooled by like the x being in different spots. It's still the same process. Okay. So I want to get rid of this 9. So I'm going to subtract 9. 13 minus 9 is 4. There's still that subtraction, right? 0 minus 1/3 x, which is just negative 1/3 x. I want to get rid of this negative 1/3, so I'm going to multiply by the reciprocal, negative 3 over 1, or just negative 3. Negative 1/3 times negative 3 is 1, times x just gives me x, so x is negative 12. Okay, so that's multiple steps. Gonna start adding a few more steps here, right? So now we're gonna start adding maybe some like terms on each side. Right, so I can combine my like terms here. 3x plus 5x is 8x minus 7. Right, and then it just becomes what we saw just before. I'm going to get rid of my 7. Going to divide both sides by 8. Now let's throw in like a distribution in there. All right, we're making it a little bit more complicated, but we have all the tools. You learn how to do this with expressions. Now we're just applying it to actual equations. Okay, so I want to try and simplify this. So when you start getting really complex like this, the first thing I like to do is simplify both sides. So this side's already simplified. I work on simplifying both of them first, and then I start transforming. Okay, to solve. So yeah, simplify and then transform. So I'm not going to be adding or subtracting or multiplying, dividing to any side yet. I want to try and simplify this side first. So first way I can do that is distribution. Right, 6 times x is 6x. 6 times 2 is 12. Right, and I only distribute in the parentheses, right? And then plus 5x. I can add my like terms. Now I can transform, right? This is simplified as much as I can go. This is already simplified. Now let's transform. Right, so I simplified. So I'm going to add 12. Divide both sides by 11. Gives me 1 and 5. So x equals 5. And I guess we haven't done a check in a while, but you can always check. What I'm going to do is plug, since x is 5, they're equal to each other. That means I can plug it into x. And I have to plug it in every time x shows up. So it shows up twice in the original, right? So 6 times 5 minus 2 plus 5 times 5 should equal 43. So let's check. Let's make sure that comes out to 43. We'll do PEMDAS. 5 times 5 is 25. 6 times 3 is 18. 18 plus 25, so you get 35, 40, 43, right? We get 43. Checks out, statement's true. This is the correct answer. Okay, so yeah, when you start getting complex ones, that's when I start doing checks, just because I'm like, I could have easily made a mistake somewhere in all of these steps, so I'm just going to double check that I solved it correctly. All right, and so I get x equals 5. We'll do one more. And then, oops. Or actually, we'll move on. So, students sometimes get a little thrown off when you have variables on both sides. So if you remember, we can combine like terms. So your new first goal is to get x all on one side. Okay, and we can do that by combining like terms. So I want to get rid of x on one side. So I want to get rid of the 5x, right? And we'll just want to have x on the left side. The way I can do that is just by subtracting 5x, right? Because 5x minus 5x should give me 0, right? And if I'm going to do it to that side, I need to do it to this side, and they're like terms, so I can combine them, and I get 2x. And then I carry down my 18, divide by 2, x equals 9. So get x all on one side, so I transformed like by transformation. Then I would simplify, you know, if there's anything to simplify on either side, and then you transform again to solve. So we keep adding, like, our steps get longer and we keep getting a new first step. But otherwise, you know, hopefully it's all the same. Okay, we have x again on both sides. I want to get rid of x on one side. You can really do any side you want, but I would recommend getting rid of the x that's like, you know, x plus or minus something and moving it to the other side. So I'm going to get rid of this 3x. That way I'm left with something, so I'm left with 55 here. 8 minus 3, 5x. Divide by 5. X equals 11. We want to do a check. Oops. 3 times 11 plus 55 should equal to 8 times 11. 33 plus 55 is equal to 88. 88 is equal to 88. Checks out. So I solved it correctly. Right? Yeah, so that's, you know, it's just one extra step. Just try and get all your x on one side, because you can add and subtract like terms, so it should work out. But basically, you have all the tools now to solve based off of what we learned last week with expressions and how to simplify them. And then we learned how to transform equations. You should be able to solve these pretty, like, complex equations like we did up here. Yeah. So the next thing I will cover is literal equations and the distance, rate, time.